Bismillahirrahmanirrahim. Dear students, grade 12, lecture number 29, and we are continue the test for the halogens and the test for the sulfur by using a Lezine solution. So last time we completed the test for nitrogen individual and test for the nitrogen and sulfur by using Lezine solution. Now test for the sulfur by using Lezine solution. So Lezine solutions, you know, it is called a sodium extract, and if there is a compound, organic compound containing sulfur, so it is going to be from sodium sulfide. Actually, in the Lezine solution there is a sodium sulfide, sulfur is there. So take a small portion of the Lezine solution containing sulfur, and he said acidify with the acetic acid. So sodium sulfide is there, and plus acetic acid, aqueous. This is acetic acid, aqueous. Then it will give the hydrogen sulfide gas. Hydrogen sulfide gas it will give, and sodium acetate. Hydrogen sulfide and sodium acetate is going to be formed. Actually, hydrogen sulfide is a very bad smell gas, or it's not good, which is going to be formed in the rotten eggs and in gutters and other their points. It is going to be formed. So this is hydrogen sulfide gas. Now you have to add lead acetate. Lead acetate, CH3COO. So there are two choices. You have two choices. In the laboratory we have lead acetate papers, small strip, just like newspapers. Lead acetate papers. So if you dip the lead acetate papers here when the hydrogen sulfide is going to be formed, so it turns black. It turns black. The lead acetate paper turns black. It confirms that sulfur is present in Lezine's solution. Organic compound is given you containing sulfur, just like thiourea. Thiourea contains sulfur, or other compounds may be present. So take a small portion of Lezine solution, acidify by using acetic acid and boil. Hydrogen sulfide gas is going to be evolved. So lead acetate paper, or if paper is not available, then you have a lead acetate salt. Just add in small water, then add few drops of the lead acetate solution with the hydrogen sulfide. You will get a black lead sulfide. Lead, black sulfide and acetic acid will be formed. Like this one. So this black color indicates that sulfur is present. Black precipitate. If you add aqueous lead acetate, if you dip the lead acetate paper, it turns to black. So this is the test for the sulfur. Now test for halogens. Test for halogens. It means that you have a sodium halide in the Lezine solutions. Maybe these are the form of chlorides, maybe in the form of bromides, maybe in the form of iodides, no fluoride. Chloride, bromide, or iodide means maybe you have a sodium chloride, maybe you have a sodium bromide, maybe you have a sodium iodide in the Lezine solution, in the sodium extract solution. Okay. Take a small portion of the Lezine solution. Already I told you have a full test tube, and you are using from the test tube. That's it's called the stock solution. So from the stock solution, using slowly and gradually sliding little amount of the Lezine solution you are using here. Boil it. Expel off the cyanide ions after boiling. Then you have to put, this is the sodium extract or Lezine solution contain halogen, aqueous, boil, cyanide ions are going to be extracted. Then you have to put a silver nitrate aqueous solution. It's expensive, but you have to use very carefully. Few drops, highly soluble in water. Silver nitrate is a highly soluble in water, small, very small few drops you have to put. So you will get a precipitate of silver halide and sodium nitrate. This precipitate will give you the maybe chloride ion, bromide ions, or if you have there iodide ions. So students, when the chloride ions are there, if chloride ions and you are adding silver nitrate aqueous, so you will get a white precipitate of silver chloride. PPT, precipitate. So you will get a white precipitate of silver chloride. So when the white precipitate form, chloride can form. You will get different precipitates of halides ion. So when you will get the white, because you will not see the chloride ions in solution, even bromide ions and iodide ions are invisible. You have a solution with a transparent. So when you add silver nitrate, if heavy white precipitate form, confirms that chloride ion or chloride is present in your organic compound. Now students, if you have a bromide, so the precipitate will be silver bromide, solid. Which will give you a yellowish but not very dark. This will give a pale yellow color. Pale yellow precipitate is formed in the bottom of the test tube, confirms that bromide are present in your organic compound. Lezine solution, I am using Lezine, these are Lezine solutions. This is a Lezine solution. You prepare very means early in your test tube, and you are testing the nitrogen individually, nitrogen, sulfur, then halogens. So this is the Lezine solution. Maybe the student has a halogen, maybe chloride here, maybe bromide here, maybe iodide here, according to the examiner. So if he has a bromide, must the Lezine solution contain sodium bromide? By addition of silver nitrate, the pale yellow precipitate form confirms that the organic compound is given contains bromine. So bromide is confirmed. Okay. So if the iodide, if Lezine solution contains iodide, sodium iodide, so precipitate of silver iodide is formed, which is a bright yellow. Bright yellow. Bright yellow color of the precipitate is formed confirms that organic compound contains iodine. So students, deep yellow, bright yellow color is going to be formed. So these are the tests for the nitrogen and sulfur combined, sulfur individually, and chloride, bromide and iodide by using Lazarine solutions, or we call sodium extract solution. So we end here by using Lazarine solution. Now students, you have now seen detection of oxygen. Detection of oxygen. How oxygen can be detected? There is no conclusive test for oxygen through the presence of organic compounds is often inferred by indirect method. There is no conclusive test for the oxygen, but indirect method. So written here, listen carefully. The substance containing oxygen is going to be heated alone in the dry test tube. No water, nothing present in the test tube. Dry test tube, put the compound containing the oxygen and heat it. Preferably in the atmosphere of nitrogen, means in air, they are 78% nitrogen. The formation of droplets of water on the cooler part, cooler part of the test tube, air, you are heating air. This is a cooler part, this contains water, droplets. This shows presence of oxygen because water contains oxygen. So this is the test tube, dry, no water. Put the organic compound containing oxygen and heat it. So when it is going to be heated, it is going to decompose. So here in the top cooler part, droplets of water are formed and water contains oxygen. So this is going to be confirmed. Maybe negative test this come. The second method is test for the presence of oxygen is maybe the alcohol hydroxyl group, other compounds containing carboxylic acid, COOH group, aldehyde and nitro compounds, they contain oxygen. If any test these detected to presence of oxygen is going to be confirmed. The shortage of oxygen depends upon determination of percentage of other elements present in the given compound. When you are going to calculate the chemical method and you are going to calculate the percentage, so difference of percentage can be detected by the oxygen. Some of these percentage should be 100, short of this is called oxygen. Suppose other elements are 80%, so total 100, so 20% means oxygen is there, short of 100. So this is the detection of oxygen. C, detection of phosphorus. Phosphorus. The solid substance is heated strongly with an oxidizing agent, suppose concentrated nitric acid. Concentrated with a concentrated nitric acid, suppose you have to heat this phosphorus containing compounds with a mixture of sodium carbonate. Mixture of sodium carbonate you have to put also, and potassium nitrate. Heat with a concentrated nitric acid, add sodium carbonate, add potassium nitrate. The phosphorus present in the substance has been oxidized to give a phosphate. It gives phosphate. This is phosphate is going to form. The residue is extracted with water, extracted, boiled with some nitric acid, then hot solution of ammonium molybdate. Ammonium molybdate formula is NH4 whole twice molybdenum oxide. This is the ammonium molybdate. It is a reagent. Solution of ammonium molybdate is added in excess. A yellow coloration precipitation indicates the presence of the phosphorus. Yellow. Maybe precipitate, maybe color. So again, organic compound containing phosphorus heated with the concentrated nitric acid, followed by sodium carbonate, potassium nitrate, phosphate is going to be formed in the solution. Then you have to put ammonium molybdate and heat it. You will get the yellow color of the solution or precipitate. This yellow color indicates that phosphorus is present in the organic compound. Now, some organic compound contains metals. Maybe the metals are there. How the metals are detected by using the test? There is a cyanoacrylate material. This is called a cyanolysis, and line is small. Cyanoacrylate material which is called crucible. We call it crucible. C-R-U-C-I-B-L-E. This is the cyanolysis, and this is called crucible. So by using a bare curtain, and you have to put on oxidizing flame, preferably in the platinum, till all the reaction ceased. Put the sample here containing organic compound metal, dry, heat it, and the whole combustible material, carbon, maybe oxygen, maybe other, they are going to be combust. Metal is not going to be combust. Remaining incombustible material is a metal. Till the reaction is ceased, an incombustible residue indicates presence of the metal substance. The residue is extracted with the dilute nitric acid solution, and test the presence of metal radical by using salt analysis. There is a major experiment. You have a salt analysis. How you detect the positive radicals, we call basic radicals, and how you detect just like sodium chloride. This is the positive, this is the negative. This is the basic radical, and this is the acidic radical. So there is a complete analysis we call salt analysis. This is the detection of metals. Dear students, here is the end of this chapter. Small chapter was open the book. You have the exercises questions, and you have these MCQs. The major portion of natural gas is the methane. Organic compounds of carbon forms to form a covalent bond mostly. The following aromatic compound is a benzene. There are few homologous series of compounds. The existence of homologous series due to the functional group. Which of the compound is a heterocyclic? Pyridine. Heterocyclic means the organic compound containing other than carbon and hydrogen atom. Carbon may be, hydrogen may be, but maybe nitrogen, maybe oxygen, maybe sulfur. So if the organic compound contains other than carbon and hydrogen atom is called heterocyclic organic compounds. So students, pyridine contains nitrogen, heterocyclic, and pyrrole contains oxygen, heterocyclic. Thiophene containing sulfur, heterocyclic, means the option all of the above. Alcohol. A. Ethanol is alcohol. B is the ether. C is carboxylic acid. D is alkyl halide. Lezine solution, we use the metal sodium. Not aluminum, not iron, not copper, only sodium we use. Silver nitrate is added Lezine's solution for the detection of iodine, deep yellow color for the iodine. Yes. When water vapors are passed over the anhydrous means without water molecules, copper sulfate, then deep blue colors will be formed due to presence of water, which is called hydrate. The simplest molecule of buckyball contains carbon 60. If the molecule contains more than one functional group, we call polyfunctional groups. So these are the questions you have to do. A functional group, we done this difference between partial and total synthesis in the previous lectures. Already I done fermentation, coal, new allotropic form of the carbon, that's buckyball, Buckminster Florence. Homologous series we done, how sulfur can be detected by organic compound, now I told you. So these questions you have to do in your copy. There are other questions, very simple. Name the molecular formula of fourth member of the homologous series 4-butane. What is a butane? Butane has formulas, isomers, N-butane and isobutane, to which the homologous series of the following compounds molecules belong. So this one is a branched 1, 2, 3, 4, 5, 6 alkane. 1, 2, 3, 4. Like this one. This is the method how to write CH3 nonsense valence. This is a condensed structural formula. Condensed. Like this one. So this is the alkane branched. 1, 2, 3, 4. 2, 3 dimethyl butane. 2, 3 dimethyl butane. So this is the alkane. And second one is a alkene. Second one is a alkene. Carbon. How many bonds? Double bond. Like this one. Then hydrogen, yes. So this is the alkene, and how we give the name? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Longest tail is 4. The rule is that start from that side where the double bond is near, and if there is a branch, then you have to start from that side. 1, 2, double bond second. 1, 2, double bond second. 1, 2, double bond second. But here 1, 2, hydrogen only satisfy. 1, 2, there is a branch. So you must start from downward or upward, it is your choice. 1, 2, 3, 4. This is a branch. 1, 2, 2 methyl. 2 methyl and the double bond is in the second. So 2 butene. 2 methyl, 2 butene. So students, you have to solve other also. Propanol, this is aldehyde. propanol, aldehyde, methoxyethane, ether, diethyl, ethyl, methyl ether, methoxyether, and propanol, aldehyde. So there one is the aldehyde and other the ether functional groups. So we are going to stop here. Inshallah, next time I will start chapter number 16. The hydrocarbons, very long chapter. Now organic chemistry we started already from the chapter number 15, so please concentrate it. So next time inshallah we will meet and start chapter number 16. Thank you.